Section 3, analyzing functions. We're still in learning target 2, but the good news is this is the last part. So part D is 2 points from a scenario. So same things we've been doing. We're going to find your slope, your y-intercept, and then put it into that linear equation format of y equals mx plus b. So as usual, stop the video, write down these 5 steps. And while you're writing them down, don't forget to think through them so that when we do them here in a little bit, it comes more natural to you. So scenario 1, Bill is working this summer to increase his savings for college, savings account for college. He plans to check his savings account every 3 weeks. After his first 3 weeks of working, Bill had $586, and after 6 weeks, he had saved $622. So first of all, you are to identify the 2 points from the scenario. So you don't have a graph, they're not given to you, they're not in a table, you just have to read through it and kind of think through it. So I know the 2 things that are changing here are weeks and money. So that's the way I'm going to set it up. So weeks is your independent or time, and then your dollars is your dependent. So how much he saved in dollars. So it says after his first 3 weeks of working, he had saved already $586. So that would be your first point. And then after 6 weeks, he had saved. So 6 weeks, he had saved $622. So now we're going to go ahead and solve for the slope using those 2 points that we just made in step 1. So we'll call this one my first set. This one is my second set. And again, your equation is y2 minus y1 over x2 minus x1. So your your y2 is 622. Your y1 is 586. And then your x2 is 6, and your x1 is 3. And that makes sense because we know every 3 weeks he's checking it. So 6 minus 3 is 3. At the top, 622 minus 586 is 36. And 36 divided by 3 is 12. Or you can write it as a ratio 12 over 1. So $12 in 1 week, or just the 12. Solve for the lovely y-intercept. So we'll just pick that first point there, 3 weeks, $586, and we're just going to plug it in like we've done. So y, which is $586, equals that slope we just found of 12 times the 3 weeks, and we're looking for the y-intercept. In other words, how much money did he have in his account, Mr. Bill? So 586 equals 36. Add your y-intercept, and then you're going to subtract 36 because we don't want 36 on that side. So we have 586 minus 36 is 550. So our y-intercept is 550. So in the storyline, Mr. Bill had saved $550 already. Make the equation y, which is the number of, or how much money he has saved, equals, looks like he's saving $12 a week, times the x, how many weeks he saved, and the y-intercept is how much money he had at the beginning, so 550. We're going to check here by plugging in those 2 points. So that first point was 3 and 586, and the second point was in 6 weeks, he had $622. So y, which is 586, equals 12 times 3, and add the 550. 12 times 3 is 36. Add 550, which would be 6, 8, and 5. So notice both sides equal the same amount of 586. So I know that is correct for that point. And then the second point, y, of course, this time is 622 equals the $12 per 6 weeks plus $550 that we started with. So 622 equals 12 times 6 is 72. Add it to 550. So 622 equals 622. And I can guarantee you that both those points are within that equation. Our next scenario, we have Brianna. She is training for cross-country season. She decides that she needs to document her average of total miles in the summer. At the end of 2 weeks, Brenna has ran 60 miles total, and 2 weeks later, she has now 100. So what are our 2 points? So our first point here is at week 2, because I can hear weeks and miles as my 2 variables. So week's going to be the independent, so that's going to come first. So in 2 weeks, we have 60 miles. And in 2 weeks later, now be careful of that because we don't want to put 2 again because that wouldn't make any sense. 2 weeks later it would be 4. She has 100. So solve that equation. So we're going to take your y1, I should say x1, y1, x2, y2, and we're going to put it into that formula. So your slope equals y2 minus y1 over x2 minus x1. Y2 is 100. We're going to subtract that from the lovely 60, which is y1. And then x2 is 4, and x1 is 2. So we have 100 minus 60, which is 40, and 4 minus 2, which is 2. So we get 20 over 1, which is 20. Solve for the y-intercept. So I'm just going to pick the point to 60, and then I'm going to plug it in here. So my y, to find my y-intercept, is y equals, my slope I just found was 20. So 20 miles in a week there, times, whoops, I forgot to put the 60 there for the y, didn't I? 60 equals 20 times the 2 weeks plus our unknown b's. In other words, how many miles has she ran already? So 60 equals 40, because 20 times 2 is 40. Add the b. I'm going to subtract 40 to get b by itself. So 20 equals b. So both of them equal 20 here. So write the equation. Y equals, the slope is 20, which is 20 miles in a week, plus she must already had ran 20. So all we have left to do is check this. So we had 2 weeks, 60 miles, and then we had 4 weeks and 100 miles. So y is 60, so 60 equals 20. The x here is 2, and we're going to add 20. So 20 times 2 is 40, add 20 is 60, so 60 equals 60. That works, so that one works. Let's try this one. Our y is 100, so we're going to go 100 equals 20 times the 4 weeks, and we're going to add the 20 miles at the end there. So 20 times 4 is 80, add 20, which is 100. So this proves that this equation would contain those 2 points. And our last scenario for the night, or for the day, I should say. Christian is a baseball card collector. However, he decides his collection is becoming much too large, and he needs to share some of his cards with his friends. After he shares his cards with 5 friends, he knows now he has 485 cards. And after he shares his collection with 10 friends, now he has 445. So I hear in here the cards, I should say friends is first because that's independent. And then cards, what's left is your dependent there. So the first thing I hear is 5 friends and 485 cards. And then I hear 10 friends and 445 cards. So my slope is going to be, as we have done over and over here, I'll use that as set 1. This is going to be my set 2. So slope is y2 minus y1 over x2 minus x1. And y2 is 445. Y1 is 485. X2 is 10. X1 was 5 friends. So we have a negative 40 at the top, which shouldn't surprise you because he's giving away cards. So the slope would be going down and 5 friends, which means he's giving about 8 cards away every 1 friend. And we might just write that as -8 there. Okay, use the point. I'll just use that first point. Again, you can use that second point if you want. It doesn't make a difference. It just will look a little different than mine. So y here is 485. We're going to multiply that by the slope I just got, which was -8, times that 5 friends, and we're looking for b, which in this case, at the beginning, we want to know how many cards he had. So working our algebra here, -8 times 5 is -40. To get rid of -40, we're going to add 40. So 485 plus 40 is 525. So Christian had 525 cards in his collection. So write the equation. Y equals -8 times x times the number of friends plus the 525 cards he had at the beginning. So take that first point, which was 5 and 485. And then that second one was 10, and he had 445 cards left. So we'll do the math, make sure we are right with our equation here. So 485 equals -8x. Whoops, I forgot. We don't want the x in there, we want the number. 8 times the 5 friends plus 525 cards. So -40 plus 525 does equal 485. So I can be assured that that works. Again, we'll go over here. So y is 445 equals, the slope was -8 cards, giving away 8 cards. This time 10 friends and $525 in his collection to start with. So 8 times 10 is -80. Add that to 525, which would be 445. So both of these check, which means this is the equation I was looking for.